Hello, Phil Whiteman, Lake Tech Communications. Here we are with part 4 of our 4-part series for VXLAN. In our previous 2 parts, we covered using NetConductor to deploy the underlay and the overlay. In this one here, we're going to use NetConductor for group-based policy to demonstrate microsegmentation. So here's where we can define policy to prevent one client from talking to another client on the exact same layer 2 segment. So let's go ahead and get into it. Okay, so we're going to focus on these 2 clients on the exact same VLAN here. So these are the same 2 clients that we demonstrated connectivity before. We don't have any group-based policy configured yet. Nor do we have any authentication running for these clients. So in order to leverage group-based policy, we do need to enable authentication so that we can, whether it's 802.1x authentication or MAC-based authentication, we need to enable authentication on the switch port so that we can establish a role. So we still have all of our EVP and connectivity. So we get a bunch of clients here. We have the same 2 clients we looked at before that are connected to each side of the campus here. And we still have our same environment. So in order to enable group-based policy, and we call that client roles here in Central, we do it globally because any switch that's participating in the fabric should be able to realize the roles. So we're going to do this globally. So anywhere we deploy a fabric or have things participating in VXLAN, they will be able to realize the roles here. So we're going to create a couple, 3 different roles. First one being employee. And this here is saying that if employee is trying to talk to something on the other side of VXLAN that doesn't have a role assigned, go ahead and allow forwarding of data anyway. So this could be, we may not have defined a role for something else in the same segment yet. We want to allow it to talk to it for now. Okay, so to find another role, we'll call this contractor. Same thing here. We want the contractor to be able to talk to things that are not defined in VXLAN. And we're going to go ahead and say that everybody can talk to everybody right now. So we're gonna play with this here in a little bit. Okay. And then lastly, we will do one for IoT. Same thing here. And we're going to allow everybody to talk to everybody. Okay. And then turn it on globally. So here we are. So this is our configuration. So now we should see group-based policy being deployed here momentarily, and we do. So that's great. So we have deployed already because we defined that first, and we should see contractor and IoT pop in here momentarily. Anytime now. Should see it. Let's take a look at our synchronization state. We're in sync. Okay, so while we wait for that to synchronize, let's go ahead and get this set up so we can at least have everything sync at once. So as we looked at before, we skipped this role step, so now we're going to say that those 3 roles can participate in VXLAN. Okay, there we are. Now we're getting the other roles here. Now we got the contractor, employee, IoT. We can see here that we have our classes established. So this is basically the ACL build out for these guys. So we have contractor. That's we're looking at V4, V6, and MAC address. So V4 and V6 are pretty straightforward, but that's where the power comes in right here, is the MAC address ACLing. So this is what is allowing us to say, hey, contractor, can maybe see itself, but it can't see employee, or vice versa, or it can see IoT, but can't do that. And it's doing that at a layer 2 level, which is awesome because they can be adjacent to the same VLAN and not even hear the broadcast traffic that the other clients are maybe using. So if we take a look at clients here, we don't have anything that's authenticated, so nothing's realizing these roles yet. So we need to not only configure the client for authentication, but we need to configure the switch for authentication. So let's go ahead and get that going here. So starting with Central, let's go ahead and get our switches configured for authentication. So I already have a Radius server configured, and that this Radius server is ClearPass. So we're going to go ahead and define this here. This is running in the ESXi environment that we have connectivity to. Give it my super secret shared secret here. No, we don't want anything remembering that. All right, so this is because we're at the group level. That server, that authentication server is going. This authentication server, which is ClearPass, is going to it's going to be configured on all the switches. So let's likewise make sure that ClearPass is configured appropriately for the devices to establish communication with it. And I'm just covering the entire 10 subnet, which would cover all the switches that have a 10 dot address, and that's a shared secret that we defined just a second ago. So we should be good there. So let's go ahead and let's go into each switch directly, and we will configure the device for authentication on the individual switch ports. Do this at a group level, but maybe I don't recall if really 111, 112, 113 on each switch are if I want authentication enabled on them. So we're going to do 802.1x and Mac authentication because I can't remember which I have Windows clients on and which I have IoT devices on, because IoT is not going to do 802.1x. We're going to authenticate it via Mac auth. So here we are. So I'm going to go ahead and do that there. And we'll do the same thing over on the other switch directly. Which, I guess I'm going to go ahead and do all three of them anyway. I guess it can't hurt because I don't remember what's on what. But just demonstrating the ability here that we can go into the switches directly to do the configurations without doing it from the global level. Not that I needed to demonstrate that, but we're into it now, so let's keep it going. Okay, so we have an authentication enabled on all three interfaces on both switches. Let's go ahead and give that a look-see. Okay, nothing yet. Okay, here we are. So we got authentication enabled on 111 on the switch here. And we actually have a client that's already authenticated and has got a role of employee. So if we take a look over at Access Tracker here in ClearPass, we can see that there's my authentication there. I did do 802.1x authentication from that machine, and based on attributes that were assigned via IDP or all sorts of other things, we are assigning roles. Same thing with Carrie. What I'm just to show you kind of a little behind the scenes here, I'm using PEEP. In my roles, I'm actually cheating a little bit. I'm using local roles within ClearPass, or I'm sorry, local user repository in ClearPass to specify those roles. And then based on those roles, I'm sending enforcement down to the switch to position them in roles on the switch. So that's what we're looking at here. So if we take a look at what got sent down to the switch, it's just sending a user role of employee for myself. And for Carrie, who is my contractor, we're sending contractor. Now again, I could have done that through Active Directory, security groups, Azure, all sorts of different ways to identify clients. So let's get out of here. And yep, still authenticated here. Let's take a look over the other switch. let's see what we got for authentication on this guy. There, we got Carrie. So we've got Carrie on one switch. I'm on the other switch. Same VLAN as we already know. We're on VLAN 100. So let's go ahead and jump into these two guys and take a closer look. Okay, as you see, I've been doing some testing, so make sure these videos go well for you guys and I didn't forget something. So here's how authentication is enabled on an interface. So on my physical interface, I have PEEP enabled for 802.1x, and there's actually a service that needs to start it on the Windows clients too to enable 802.1x, but we are doing PEEP. That's what's presenting my username up to ClearPass for authentication. And it'd be the same thing over here in this guy, except for contractor. Okay, so we have one other device we're going to bring into the environment here. Let's use, I guess, this guy. Yeah, that looks like an IoT device. Looks good to me. And specifically, I think it looks like maybe an Apple TV. All right, so now we have clients on. We have three clients on VLAN 100, 2 on one switch and 1 on the other. Let's take a look at that. It looks like, yeah, my Apple TV has not got a roll yet. Things in progress, so maybe being a little bit stubborn. Might need to go in, cycle this device here. Let's make sure it's got yeah, Apple TV. That is the right port. Still in process. Don't see anything coming in the ClearPass yet. Sometimes these clients can be stubborn, but let's let me actually need to. We can go into what we call support mode so that we can make local configuration changes. So that's what I'm going to do here. I'm just going to cycle this port to get that Apple TV to forward some traffic to kick off the authentication event here. Sorry about my typos. So here momentarily we should see authentication kick if we're to get an IoT roll. It's a great thing about doing things live on the fly, as we get to wait. Let's see what's going on here. Okay, I do have 802. Oh, because we have the delay here, so it's gotta wait for the delay, and I could put it in different orders here. I could say do it at the same time. I could say just do Mac auth. So what we're waiting on here is a timeout of 802.1x. So the switch is asking, "Hey client, can you do 802.1x?" And it's waiting for it to respond to that, and it's not going to roll over to Mac authentication until the timeout periods have exceeded, which are completely adjustable. But since I just took, the UI here and I just did a basic deployment, I didn't tweak any of that. So let's take a look at some other stuff here. Let's maybe tweak this a little bit. Let's just go ahead and shove Mac auth down. I don't know what we have some delays set there, but instead of us waiting a couple minutes for this to happen, let's make this happen right away. Okay, so config changes haven't come down yet. It's still enabled for .1x and Mac authentication. And momentarily here, we should see the .1x go away. And again, the timers would be completely configurable, and oftentimes it will do concurrent auth, so there is zero delay. All depends on the environment. There we are. Got concurrent enabled now. Let's cycle this guy one more time, so we don't even see the Apple TV doing anything. There we go. All right, sorry for that, folks. So now we just did a concurrent Mac auth, which got it to go up there immediately as soon as the Apple TV started forwarding traffic, got authenticated. Now we have an IoT role. So great. So let's demonstrate getting. We'll get some IPs. So we're going to toggle the IP tracker because remember that was deployed initially. The IP tracker is also deployed per VLAN. So just toggling this here will get us some IP address visibility here, just so we can see from the switch's perspective what the IP addresses of these clients are. I don't want to do that. Let's do here. Okay, so yeah, so we got IP here for D6D0, which is the Apple TV. I think. There we are. So we have the client IP. So now we know what's what. Sorry about all that jumping around there. So we can see here that everything can ping everything. Of course, I can't jump on the Apple TV to demonstrate pinging in the other direction, but you can see that employee can ping IoT, employee can ping contractor, contractor can ping employee, and contractor can ping IoT device. And it's doing that all over VXLAN. So now let's do our microsegmentation. So if we edit our roles here, see that everything's allowed to everything. So let's not allow employee to talk to IoT. Maybe our contractor is the one that maintains that particular IoT device. Employees have no business in touching that IoT. So if we look at it here, employee's not in the mix at all. So employee cannot talk to IoT. At least that's what we're telling the system. Okay, so if we jump back over to our RDP sessions, should see here momentarily that the employee won't be able to ping the IoT device. There we go. And it's down. So, and because we adjusted policy for the IoT device, we see that it actually stopped pinging over the employee as well, or the contractor. That's just because policy is being affected, and it takes a little bit of time before full policy is realized on the switches. So I'm sure there'll be enhancements to this in future releases of CX where we can real-time modify our client roles and policies, so our group-based policies, so that they will, so we don't have to go through delays. So IoT is basically down for everybody right now until policy is fully implemented and realized on the switch, which we should see here momentarily. There we are. Okay, so we've got employees can talk to contractors, contractors can talk to employees, employee cannot talk to IoT, but contractor can. So very good. So we just affected microsegmentation here, which is super awesome. Maybe again some enhancements there for maybe some real-time modification of policy, but that's group-based policy. We're going to see lots of advancements come into that as new releases come out. Thank you.